working, everybody? Give me some nods. Hello, everybody. I'm Justin Noble. I'm the Director of Products and Applications at Xaar. As you heard, I've been there 14 years. I started off as a mechanical engineer, but please don't ask me any physics-based or chemistry questions because I'm not allowed to answer those anymore. I've been demoted to commercial roles. Quick snapshot about Xaar for anybody who's not from our little inkjet universe. So we started off about 35 years ago. We were a spin-out from Cambridge Consultants and Cambridge University. We developed some novel piezo drop-on-demand technology. We started licensing that, so you'll recognize names like Seiko and Toshiba Tech on there and Konica Minolta. Their first products that they took to market in inkjet were all based from our licensed technology, and some of their printheads still feature that licensed technology today. Around 2007, we moved from being a technology company into a product development company, so we invested in our own manufacturing and our own printhead product line, and that's what we've been doing ever since. So this is what we do in coding and marking. So Xaar's working across a massive amount of applications, but packaging and coding and marking is a big part of that for us. So there's just some images here around some of the snapshot applications that we're working in. So on the top left, you can see this is large character secondary packaging, coding and marking. You can see a 1D barcode and some graphics being put down. That's normally oil-based. That's probably about 25% of Xaar's business right now, so it's a big part. Top right, that's label embellishments. That's a UV application. We're putting down a digital varnish, and we're embellishing a pre-printed either analog or digital label with varnish or foiling adhesive. Down the bottom, this is a direct-to-shape application, so those are finished cans, and we're spinning them with our OEM and decorating them with a UV graphical design. And the bottom right, that's a corrugate sheet-fed water-based application. Just on the bottom, these are some of the products that we're using within the packaging space. So that big boy at the back, that's our Versatex print bar. So that's a bolt-on turnkey solution. It's based on narrow web, so 17 inches or 430 millimeters wide, what you'd typically find on a flexographic label press. And the bottom corner, that's a range of our printheads. So you can see we've got a single row at 180 dpi, and that moves all the way through to 4-row printheads at 2002 or the Equinox based on 720. We don't just do printheads, although they're on the left. We also bring to market electronics and data path with partners or our own. We have a range of optimized fluids that exploit our unique capability. For those fluids, we have fluid management systems. And then the last one, you just saw an example. We also take to market subsystems, like we call them print engines. That's a combination of ink systems, electronics, and the printheads. And also full turnkey systems like the print bar, where basically you've got everything you need inside the box. Xaar's got 3 really foundational, fundamental technologies that differentiate us from some of our competitors, and I'll just take you through those really quickly. So the left-hand one, most important in my opinion, is our patented through-flow technology. We talk about it all the time because it enables all of the other technologies that we then leverage. So this is a recirculating fluid technology. You can see in this diagram the fluid is going right behind the nozzle. What that means for us, you can see some particles and air bubbles there. It basically keeps those out of the way of the nozzle and really gives you an industrial reliability. We can manage more particles within our fluid. You can get a heavier pigment loading with larger particles. You can see if you have an air ingestion event like we just saw there, that's whistled away from the nozzle. You don't get any line outs or drops in reliability. Because of that through flow, we can also jet really, really viscous fluids. So that fluid in the middle there, that is actually a flexographic varnish. It's about 1,000 centipoise in the bottle. We heat it up to about 65 degrees Celsius, and that puts it around 100 centipoise, which is our maximum viscosity range. And lastly, this is high laydown technology. So that printhead in that example is a 6 picoliter drop size natively. And what we can do with a flip of a waveform, we can change that 6 picoliter drop into a 60 picoliter drop, giving it a lot more mass It means for applications where you're trying to put down a coating, you can get a really, really efficient productivity. You can lay down thicknesses of varnish at 100 microns at 50 meters a minute. Or if you want to move really, really fast, it means you can run your web or your sheet at speeds of 300 meters a minute. Because we're depositing so much fluid, we can keep up with that process. So in this example, we're depositing basically a Coke can's worth of fluid in 1 minute. I just wanted to talk a little bit more about viscosity. Apologies for any chemists or rheologists. This is obviously very basic, but to give you the ballparks, centipoise is the unit of measure. Water is 1 centipoise. Cream is around 20. Olive oil, 65. So most printheads out there doing a digital piezo deposition, you're really maxing out between 30 and 40 centipoise at jetting temperature. If you're trying to do water, actually it's even less than that. It's down to about 10 centipoise. With a Xaar printhead at jetting temperature, you can see we're up here, 100 centipoise. And all the way down, not quite to as low as some of the competing technology, more about 5 centipoise. But it just massively opens up the range of fluids that you can jet within our technology. And as I said earlier, at room temperature, that 100 centipoise fluid is now 1,000 centipoise. So you're talking about really different chemistries that you can then address with this process. This is just some examples of where we've deployed high viscosity technology. So the far left, that's a textile direct-to-garment application, so they're printing on t-shirts. And we're doing a side-by-side in most of these, so that the first image being printed is a standard viscosity fluid, about 10 centipoise, and it takes about 16 passes to get adequate opacity on that textile. What you'll see in a second is a high viscosity and high laydown print, and it's going to bosh down a really, really opaque white. You can see immediately they've been able to achieve that print much faster and with better quality. This one in the middle is particularly interesting. You've got, again, it's actually the same fluid set as the textiles there. It's a side-by-side. You've got a standard viscosity fluid jetted onto a uncoated and unprimed craft liner. And what you can see with the combination of high viscosity and high laydown is that pigment's remaining on the surface of the substrate. With the standard viscosity fluid, it's immediately sinking in, so it's completely useless. Lastly, this is a full colour sheet-fed application that we have. What we've shown here with the use of this fluid is that you can reduce your fluid usage down to 25%. And that's because you're not losing all of those pigments that are being absorbed into the substrate, and you never see them. You're getting a far greater colour intensity, about double. If the colour is okay with your standard fluid, you can reduce it down. Okay, so that's Xaar and what we've been up to. This is what I wanted to talk about today, really. So this is what we've been doing in coding and marking. So the concept, basically, is we can see from GS1 and Sunrise coming that more data-rich codes are needed. Piezo can do data-rich codes, but it can't hit the production speeds. It's this naff, sorry. That better? I won't start again. I'll just carry on from where I am. With a piezo technology, you can hit what GS1 Sunrise is requiring from a 2D data matrix or QR code, but you can't go fast enough. Over here, this is an example of another technology. This is a CIJ, and it's running at about 250 meters a minute, but you are never going to achieve a 2D barcode with a CIJ system. It's just not going to do it. So what we've now done is looked at how we can use high laydown and high viscosity to achieve the speeds that you can go for CIJ, but with the quality and image fidelity that you get from a drop-on-demand piezo device. So that was a concept. We spent a couple of years working on it. Really what we've been trying to achieve is a grade A, so a grade 4 on white substrate. And that's what we've done here. So we've got examples of 10 millimeter throw distance. I'll go into that in a little bit more. Speeds of 250 meters a minute. This is printed from our Aquinox printhead. You can just see there, which is 4 rows of 180 dpi. Because of that high viscosity fluid, we can get a far greater contrast. There's more black pigment staying on the surface of the substrate, which means you get a better code grade, and you can go faster using less ink. Because everyone will know who's got a piezo coding marking machine, as soon as you run faster, it gets lighter and lighter, your code grade goes down. So that's what we've been trying to tackle here. These are some nice videos. So top right, that's a sheet fed moving at 250 meters a minute, grade 4, 3 millimeters throw distance. You'll see us grade it in a second. That's on an uncoated white corrugate substrate. Bottom video, that's us again printing, but this time 100 meters a minute, so a bit slower. But it means we can increase the throw distance to 10 millimeters a minute and still hit that, 10 millimeters, and still hit that grade 4. So that technology is ready now. Basically, we've got some QR codes at the end of this talk. If anybody would like to engage with us, we can talk about development kits, etc., and how we can help you integrate and evaluate that technology. Just a little bit more about our roadmap. So that technology there, you can see it's summarized with the 250 meters a minute at 3 millimeters. We're going to port that over to our much smaller form factor 500 series printhead. So this is 180 DPI from a single row. It's obviously a cheaper printhead, and it is well suited for the coding and marking market. So these are the specifications that we'll be targeting with that technology. So we're talking about 75 meters a minute at 3 millimeters from a single row printhead, and 25 meters a minute, but with a 10 millimeter throw distance. On to something new. So we're launching this today. I showed you the varnish print bar a little earlier. This is now our monochrome bar. So it's well suited for black variable data, retrofitted onto flexo presses or finishing presses or digital hybrids. It's developed as a turnkey solution. It basically has everything you need inside it. So in there you can see media handling. It's got an encoder, product detect. It's a turnkey black box product. Just a little bit more about the Versatex print bar. This is the broader product range. So it started life as a purely varnish product. You can see we've developed that into a braille solution. So these braille dots here are ISO standard. They're about 250 microns in height, and we do that about 20 meters a minute. We also use this varnish bar for cold foiling and for digital embellishment of pre-printed flexo labels or digital labels. Also in the Versatex print bar product line is our opaque white. So you can see that prints at 85% opacity, so that's sort of knocking on the door of rotary screen. It's well in advance of what you can achieve with a flexo process. And we can hit that 85% opacity at 50 meters a minute. So this is the new edition. This is the black print bar. The first print bow that we're taking to market is a 75 meters a minute. So that's 720 DPI down the web. And it's been designed basically to produce overprinting, in-printing of monochrome QR codes and 2D barcodes. So just quick summary, we've got that coding and marking technology that we're now taking to market and is ready for you to test. We have the launched new product to our print bar portfolio with our black variable data print modes. And if you have any questions or if you'd like to follow up with us, just tag those QR codes. That'll take us to our landing page. We'll get in touch with you. We can organise a demo over in Huntingdon or Cambridge, or we can discuss with one of my colleagues about some more details from this presentation.
Thank you.
Any questions?
Thanks, Justin. Are there any questions right now? I have a microphone. I can hand it over. Well, here's one on Slido. What percentage of Xaar's business is in the coding and marking sector?
Spoiler alerted that one, didn't I? Yeah, it's about 20-25%. It's a decent size of our business. It has been for probably the last 10 years, I would say.
Okay. And how established is the Versatex print bar in the label market?
Yeah, so we've got about 50 of those print bars out in the field now, largely in Europe. Most of them are printing varnish embellishment onto wine labels, so it's uncoated media stock. We've just started, obviously, launching the white, and the black is new to market now, available at the end of the first half.
Okay. Okay, that's it. So, thank you so much, Justin Noble. Thanks.